So hello there, Happy New Year and welcome to the workshop. So in this workshop we will be making a VR video player on Unity where you can view videos in 360 format. So let's talk about the assembly. So the assembly is a smart lab based in N5 Tech here in Internet City since December 2014. We have done over 300 workshops since 2014 and we have done them on 3 categories. So there is the hack, which is basically IoT hardware embedded systems. Then there's the software workshops, which are just software development and coding, just general coding stuff, just like this workshop, almost similar. And there's also data, which is based on AI and machine learning. Our main target audience is just the students or professionals or any entrepreneurs, or in fact anyone who has a little knowledge or wants to seek knowledge in these tech workshops. If you want to check us out, we are there on our forums at members.theassembly.ae, where we update people on when are we going to do the workshops and also give additional fee. You can check us out on our social media on Facebook, Twitter, and Instagram at Make Smart Things, and also check our YouTube page at The Assembly, where we upload YouTube videos such as this workshop. So let's get to the Unity engine. So Unity engine, like the name suggests, it's a powerful game engine, and which is also a cross-platform environment, allowing you to create applications on many platforms such as iOS, Android, Windows, Mac, and even for PlayStation and Xbox, since it's a game engine. And there are many applications developed on it, such as the really popular Fall Guys and Phasmophobia, and also Cuphead. The Google Cardboard here is one of the solutions provided by Google for VR. And at one point, like during the time when VR just started gaining its heights back in 2013 and 2014, and soon it got bundled into the Daydream SDK and created this Google XR plugin for various frameworks like the Android and the Unity. Then it got deprecated along with the VR because the VR headset got discontinued back in 2019. However, it founded its new life as an open source project by Google, and you can check them out on GitHub. They're updating stuff every now and then. And as you can see, 2 of the most popular applications developed using the SDK was the YouTube VR, which basically is YouTube but in VR format, and the BBC's Earth Live in VR. So let's go about making the VR video player on Unity. So the prerequisites would be the Unity Hub plus editor. So if you go to the installer page, it will show you the option of whether you download using only the editor or using the hub and the editor. The hub would be better since it allows you to manage other Unity projects as well, and it also allows you to manage which editor you want at a given time. So for instance, if you have multiple editors, then you can stack them inside the app and choose which one you want for your respective projects. Then it's the Google Cardboard SDK. We would be using the new open source SDK instead of the older XR one, just because it's new and it's updated every now and then. And we're also going to be using an Android smartphone just for testing and viewing the end result of the workshop. Alright, so right now I'm in the VR headset, and as you might be able to see, this is the waterfall video in VR. I'm sitting on the chair as I'm trying to immerse myself in the view, and you guys can view it as well when you finish this VR player. I will just show you 2 browser pages. So at developers.google.com/cardboard/develop/unity/quickstart, you'll basically see this quick start guide on how to use the XR plugin. This is the newer one, not the old one, the newer plugin for Unity. And these are the steps which I will go through later. However, this is also the download page for Unity, where you could either choose the version of Unity you want and download, or you could just download the hub from which you could download the Unity editor. So I'll just show you the Unity editor hub. So this would be the hub. I'm using the latest 2.4.2 version, and you could see the projects, you could see the editor. So right now I have 2 editors, and you could see some resources from what you want to learn, and some community. And before using Unity, you also have to make sure that you have the Android build support. So if I go and check add modules, you can check I've added the Android build support on it. And if I click the arrow, you can see I have the OpenJDK and the SDK and NDK tools over here. Make sure it's still selected. It's a 1.1 GB file, so it will take time. However, this is already installed, so it wouldn't interfere with the workshop for a while. And yep, this will be the one which we're working on now. So yeah, let's get onto it. So the way this would be done is that we would be visualizing a sphere inside which you would have the video feed, which is 360 by the way, just to make it clear. So in case you already have your 360 video feed, you could either have that, or you can look up on Google for any good 360 video feeds to use it. The reason we're using 360 video feeds is because it looks good inside a sphere, because you know the 360 view and VR. However, if you have your standard 1080p, you could add additional settings in Unity. You can make it panoramic, and based on that, it will allow you to view it inside the sphere. However, those are extra steps which you can proceed to do it if you want to. However, for this one, we're using 360, so to make things easier for everyone to follow. So I will create a sphere here using right-click and 3D objects. This is a sphere. Right now it's small and all that, but before that we first should go into the main camera and make it 0. So that way, if you're going to be viewing from the headset, it will be right in the center. So it would be much better to view it from there. And also increase the scale of the sphere to 50, 50, 50. So here's I will describe it to you again what I just did. So this is the position, the rotation, and the scale. So the position would change the position of the game object. See, this is what we call every object here in Unity, a game object. So you would be changing the position of the game object. This would be the rotation of it, and this would be the scale. So right now, the game view is basically showing you the inside of the sphere. However, it's not showing you as the way it should be, but I will show you how to change it later. We keep the directional light the same, and the main camera the same as well. So we will get the video here. Let's go back into assets. First, make a folder for better management called files. Now, usually in this section, these are your assets. This will contain any asset you have for the Unity. So these are the samples, scenes, and this is the XR. I will explain to you why this folder is here, and these will be the files. But usually if you're making a game or any application, you would have additional folders for scripts, materials, shaders, and the XPX models and all. So the reason why it's allow for better project management and better sorting of files. So you know where to access it from, and in case you're giving your project to someone else to use, it would be much easier for them to follow along. Right now we don't have that many assets for this, hence why I'm just keeping it inside the files for simple management. So what I would do now is I will get the video from here. So the video, I will show you how to get the video, but basically since I already have the video, I will just export it here. See if that works. Okay, so that works. The video is here. So the video, will just go on Google and type 360 video, and you can find many on YouTube or even Vimeo. So what I searched on Vimeo to get good 360 videos, but you could use anyone which you have, anyone which you ever made, or like I said, anyone. So here's the 360 view, and okay, so we have the sphere that I'll just expand it on so you can see this sphere and video. So the next step would be what people call it flipping the normals. So for that, I will give you a bit of description as to what flipping the normals is. So slide view, and so basically a normal is anything at right angle to the surface. So as you can see in the left diagram, we have the yellow flat surface, and the normals are the two arrows, one going on top, one going on bottom. So that's one normal and then the second normal. So what are we achieving by flipping the normals? So you usually have the normals on the outside of the surface because the surface is displaying on the outside. For our thing, we want it to be inverted. And the reason for that is that inside the sphere, if the camera is going to be inside the sphere and it would be to look at the videos, it's better if it's on the inside, because like if the sphere would be, if you visualize it as a sphere around me, it would be much better to visualize the video around me. So therefore the normal should be flipped so that the video would be displayed on that normal, and that would be configured by a shader, which I will show you how to do it. So in order to apply the shader, you first have to make a material. You can just right click create, and you can see there are various options. You can create animation, physics material, UI elements, but right now we just want the material, which is here, and we call it this. These are basically the ones which we made in the project. Right now this is the files folder I made, the sample scenes, and the XR plugin. So this is the test shader which we made, and would be viewing this in Atom. So if I open this, Atom, you can see it's viewable here. So this is just the basic shader, standard surface. You can see there are some attributes defined here for this italic or glossy properties. We will be changing that using this code. So what we would do here is that we enter a bit of code. So what this code will basically do is it will get each vertexes, and it will convert them, and it will flip the normals on that particular vertex based on how geometry works. So now that we saved this, we can go back here, exit the file explorer, and you can see the shader is here. And what we do is we can apply the shader, test shader. So we click this. It's there. Now what we need to do is apply the material on it. So as you can see now, it all converted into white. This is expected because once we put the VR video on it, it will display the video on it as well. So as you drag the video, so you will be dragging the video onto the sphere here, that way. And you can check the properties. This is the inspector menu. So like I mentioned, you already have seen the position and rotation and scale attributes, but these are the additional attributes which would define what the shape is. So the mesh renderer was basically how the objects get rendered. So you have a mesh, think of it as like a 3D graph, and in that, like, you have shapes created, and in that you're defining how the shape is created and what material it would have and what sizes would be, and etc., and whether it's showing the shadows or not. So over here you applied the material, and inside the material we have the shader. This would be the sphere collider. This isn't much of a concern here because we're not using any physics here, but usually a collider would just be like a barrier around the sphere, which would help in interaction with other objects. So if you have a game where you have two spheres interacting, you can define what would happen when they're interacting with each other, or how it would react when it hits something. And you can do a lot of things with it. So this would be the video player, which just got created after dragging the video onto the sphere. So you can see the video, and you can see the render mode, material override. This was overridden because we were using material on the thing, and yeah. You can see it as that, and we can try running it now, but first we need to set this. It's better, and let's run this thing. Hopefully it works. First try. Yep. So wait, mute. So as you can see, this is being played. Right now I can't move it because I'm not in the headset, and yeah, so we only seeing this in the game view. Now the game view, this is a view. Basically what this would be is that it will show anything which would be happening in the game or an application. So this would basically show the final results of your work. So over here, whatever is done, this will be showed here. The console would basically be for debugging. So it will show you any errors or any warnings of any sort. The asset store and the animation are not much of a concern. The cell menu, in fact, is pre-configured based on my preferences, but you can change and drag these up and down anywhere you want. Down, I like it down because the games are meant most probably horizontal. You can also change the aspect ratios of it. So it could be 5:4, 4:3, etc., etc. Now there's an additional element which I would want to add, and this is from the sample. So before this workshop, I already added the SDK in it. However, I will show you how you do the SDK. So you would usually go into Windows, the Window tab, and select Package Manager. And in this, you would go and add, and you can add the package from the Git URL based on this, what I showed you. This one, where is it? This thing. .git. This link, you can either add that, or you can just look this up on your web browser, and it will lead you to the GitHub page, which would be displaying the plugin itself, where you could just download the package itself and download, and you can get the link again, or you can just download the zip file which contains the package, whichever way is easier for it. In case the link over here doesn't work, which it doesn't sometimes, it will give like a 400 error, you could use this link to look up the web browser and get another thing again, if that's easier for you. So over here, this is the Cardboard XR plugin. I imported the Hello Cardboard project here because I will be using one of their files over here. So if I go into here, since this would be the Hello Cardboard, as you can see, this is already a pre-configured view. But what I want to use is in the main camera, this track pose driver. So this is one of the components which basically attracts your head. So if you're on your phone, if you would be using the phone in VR, it will track the phone's position based on that. It will show you that particular view. So what I just did was I went to the component and I copied the component, and I would be pasting the component inside the camera. of my scene. So my scene is in this folder, scenes, and it's a sample scene. I didn't change it because it's just one scene. And I'll right click any components, 3 dots, the menu, and I can paste the component as new. And now it's here. So we don't have to look at the attributes much, but as you can see, the tracking type, it tells you the rotation and position, and these are the attributes we'll be tracking here in order to adjust your particular view. And I save that. Now, main thing is to build. So we first go into build settings. And as you can see, this is the build settings. So over here, this section is scenes to build. So basically, whichever scene we would want to be built into the final build, or the one which we debugging, that would end up here, such as this one. And over here, these are the platforms which you can support. So right now it's on PC, but I want to make it for Android since Carbon SDK is already, the Carbon SDK is made for Android. So I will click the Android and switch platforms. So now it will start compiling the scripts a little bit. It will take a bit of time. So take a breather and just drink some water. What's in the hand gestures, guys, you can just shush for a while. It's going to be over soon. So, alright. So, as you can see, now Android is the primary platform now. So, what we need to do is now we need to configure a bit of settings in order to make sure it runs well on Android. So, first, what I just did was I went to the player settings, and over here we defined the basic properties of the app in order to run properly on Android. So first we changed the company's name, which is the assembly, right? This will get changed down later. And we first check the resolution tab. So it's started on full screen. We don't want to optimize frame pacing, yep. And the default resolution would be landscape left. The reason it's landscape left is that usually the VR view would be rendered as like a tiny tab, something similar to how a YouTube video appears on a portrait in a portrait layout. So by forcing landscape left, it would shift to the landscape and force the landscape left aspect to the full screen. So that's what it will try to do. Now for splash screen, we don't have anything for it. But for other settings, we have a lot of settings for it. So okay, now we're back. So I will show what I did so far. So I changed the company's name to the assembly because this is the assembly. I changed the resolution to landscape left. The reason why I did landscape left was because the VR view usually gets rendered in a similar size as to how a YouTube video looks in a portrait landscape, just to give you the idea of it. So in order to show it in VR format, so it could be placed into the VR headset of your choice and view it, yep, it should be forced into landscape left. So it will basically get that tiny frame, make a landscape, and then expose it to the left aspect. And just for sakes, the frame pacing would be disabled. Again, all of these are there on their website, the ones which I just showed you, but I will just be carrying out where with you. We don't need splash screen, and let's go to the other settings. So for the graphics API, the website tells you to remove Vulkan and just put OpenGL ES3. However, I will be keeping Vulkan just because many of the smartphones nowadays support Vulkan, and like many smartphones don't come with OpenGL in fact. So it's better if I keep the Vulkan option still there, so it's better for phone compatibility. And now what else? Now for the scripting backend, it will basically be not mono, but it would be an IL2 CPP. So it would be converted and there. And what else we have to do is for the architecture, we could define both or either one of them. They both work. And internet access is required because whenever the SDK updates, it will be updating some of its files. So it could do it over the air, or in fact, anything which your application want, like a video feed, you could also use it via the internet. It's just simpler, and everyone has internet these days, so it's fine. And yeah, what else do we have? We have optimization is fine, site choice is fine. Now to publishing settings. Now we do need to have our own custom, not this one, our own custom main Gradle template, which would be in plugin /android / the main templates. So if we check the plugins Android, we can remove this one just for its sakes, and you can open the main template even on Notepad, so it's fine. It's just entering 3 lines. So you have the lines with me. Yep, the line is there. Like I said, everything is already there on this page, so it's just me doing the extra favor of showing it to you how to do it. But like, if in case you still don't understand the steps, you can get a look of it here again in the website. So these lines, these are the things which would be required. So down under dependencies, you enter these 4 lines. So we have annotations, and notation. So one of them by the name, it's just the play services. So in order for any app to function properly on an Android phone, you need play services to be enabled inside the package. This would usually be there by default when you're making an Android app, but we're just adding it just for the sake of it, just in case the app is there in countries which don't support play services. And the app compact and the support, these two are basically libraries which would basically convert the Unity project, the Unity game, or the Unity app into an Android app. So these 2 libraries would basically be required to convert it to Android. So any classes are made inside the app compact. Android classes like the widgets or the card views or anything else sort are made using the app compact. And these would be required if you want to convert them to Android. This is there for the sake of Google. They want it there, so that's fine. So we save this, saved, and what else do we have? Next, so if we scroll down below, there is the XR settings. This was based on the old XR plugin, and it even has this tiny description of defining how it's deprecated, and this will be removed. So don't rely on that much, which is why we were using the new XR plugin here in XR plugin management. So this is the new tab which is introduced. This is after I imported the SDK. Like, this wasn't there. So yeah, when you import the SDK in, you will get this plugin management. So it's its own separate tab, and it helps you to manage what plugins do you want. So the Cardboard plugin, as it got loaded, it basically will add some additional libraries which is required for the Cardboard to function. Now, looks like everything's done. We added, let's go back to player just to check again. Publishing settings, it's fine. The other settings, yep, I added it. This is how the package name would look like. You have the version 0.1 and being made on Android 4.4. So even those could function properly in WeGuard. Close this. Now I Okay. Okay, I got lost in the folders. Right, so this is the same sample scene. Okay, so here we are at the build section again. So these are the things which would be done, and as you can see, you can just click build and run. So it will lead you to a folder. This is your project folder, so you can just define the file name. So this would be the assembly. Oh, spell assembly wrong. Assembly R video .apk. Also, I like to define tiny versions. V1, so it helps in tracking. Save that, and let's save detects my device, and let's see. And it's detected, and it will start building your app for the Android phone. Now again, I will mention that if you still, after this, you try to use the older SDK, the older SDK it will work fine for older phones, but if you're using newer phones like the 2021s, they wouldn't work since they don't have the required libraries and the plugin just wouldn't function properly. It would, if you try to launch the app in Unity, it would just stop abruptly. So yeah, just be careful. If you're still using the old Xr plugin for legacy purposes, that is, if the newer ones are not supported by your phone, for instance, or maybe just anything like that. So yeah, we're back again. This is after the app is built. So right now I'm running this on a custom viewer. It is basically emulating my Android device. So right now I am holding a device right now, but basically it's showing you the video as view in VR. So this would usually be the VR view of it. So these are the two lenses. It's done in a stereoscopic view. So the VR headset will usually have the two lenses, which would render it as per the way it would be perceived properly by human eyes. So as I move it around, you could see the waterfall, you could see the leaves, another more waterfall. I mean, it's the same waterfall, it's just I'm looking at it from another aspect. And yep, looks good to me. Alright, so thank you so much for watching the workshop. If you want to get further notifications about whenever we do our next workshop, you can subscribe to our YouTube channel and click the bell icon. Or you can just access our members forum at members.theassembly.ae. So with that, I would just like to end this workshop. Wish you a happy new year again, and see you soon.